All right, this is a final example for using the saturation tables to calculate mass or volume. It's a more lifelike example, a bit more difficult, all right? In this case, we have a suction pipe that has a pressure gauge on it reading 40 PSI gauge pressure. And this pipe is a 5-inch outer diameter, that's a nominal diameter, and it's 20 feet long. And we wanna find out how much mass of ammonia is in that pipe, okay? That's what we're tasked with. Okay, so we have to use knowledge we have about refrigeration to make some good assumptions. First of all, I told you it's a suction pipe, which means we're gonna assume this pipe is full of saturated vapor. Okay, the problem didn't state that, so we have to know that because a suction pipe shouldn't have liquid in it. Okay, so we're gonna be dealing with saturated vapor. It is ammonia, it's at 40 PSI. Now, we aren't given the volume, but we are told it's a pipe, that's a cylindrical shape. We know its diameter and we know its length. Now, a tricky thing about pipes is that the nominal diameter is not the same as the inside diameter, which is what we really need to know. So using readily available engineering reference material, I know that a 5-inch nominal diameter pipe has an inner diameter 5.047 inches. Okay, so you'd have to look that one up if you don't already know that. So that's the actual diameter. So what's our equation for calculating the volume of a cylinder? Well, the volume of a cylinder is going to be the area of the circle, pi r squared, multiplied by its length. All right, so we know the diameter and radius is exactly 1/2 the diameter. So the radius in our case, r equals 5.047 divided by 2, which is 2.5235 inches, okay? That's our radius. Now we have everything, so we know radius, pi is a number, and we know the length is 20 feet, so we can calculate the volume. But before we do that, because I have my radius in inches, and I have my length in feet, and I'm gonna wanna be dealing in cubic feet, I'm gonna actually convert my radius from inches into feet by dividing it by 12, okay? So my radius measured in feet is 0.2103 feet. All right, now let's calculate the volume of our pipe. Volume equals pi times 0.2103 feet. That will be squared. Multiply that times 20 feet. All right? Okay, we find out the volume of our pipe is 2.779 cubic feet. Great, so we know the volume and we know our pressure. So now, using our saturation table, we can calculate what the mass is. So let me grab my saturation table, okay? I'm gonna use the read it packet here, and I'm gonna go and look up for the row corresponding to 40 PSI. Now, a word of caution here, the farthest most left column is temperature in degrees Fahrenheit, and those are nice round numbers or integers. There's no decimal place. But I wasn't given the temperature, I was given the pressure. So I'm gonna have to go to the second column, which is the gauge pressure, and find 40 PSIG. Okay, and as I do that, I don't see 40 exactly, but there is 40.03 PSIG. It's close enough, that's what I'm gonna go with. And that corresponds to 26 degrees Fahrenheit. So that would be the temperature of ammonia inside our pipe. We're not asked for that. Okay, since we're dealing with vapor, I'm gonna follow the common convention, which is to use specific volume of vapor. So I will go at the 40.03 and I'm gonna move to the fifth column, and I learned that the specific volume of vapor is 5.2395. And I'll move a little bit over here. Specific volume equals 5.2395. Now the cubic feet per pound. All right, That's the specific volume corresponding to those conditions. Now to calculate our mass, I'm going to say mass equals our big volume divided by our specific volume. So let's plug those in. Mass equals 2.77, whoa, got 9. 2.779 cubic feet divided by 5.2395 cubic feet per pound. Cubic feet will cancel, pounds will go on top. Now let's grab our calculator, determine what our mass is. We have 2.779 divided by 5.2395. The answer is 0.53 pounds. So our 20-foot long, 5-inch nominal diameter pipe that's at a pressure of 40 psi has about 1/2 pound of saturated ammonia vapor in it.